All right. So today we are going to talk about currents and climate. So what exactly is an ocean current? Okay, ocean currents are masses of water that flow from one place to another. Okay, they can be on the surface of the ocean. So the surface, they can be on the top, or they can be in deep water. And we're going to talk about the difference between the two of those. We also need to know that ocean currents move water and more. So if we look up here, the journey of the ducks, okay? So 29,000 ducks left China in 1992 when they fell off the boat in the Pacific. 10,000 of them drifted up north. 19,000 go south, okay? And they wash up in Australia, Indonesia, and South America. And then we look over here, 15 years and 17,000 miles later, the Bath toys are now on course for the British beaches. Okay, so ocean currents move water, but in this case, they also move rubber ducks. So what are surface currents? Surface currents are movements of water that flow horizontally in the upper part of the ocean's surface. So they flow horizontally. So think of the horizon, okay? And they flow in the upper part of the ocean surface. So the energy that drives the surface ocean currents comes from wind, because think about the wind, okay? That's going to touch upon the surface of the water. Next is another term. What are jars? Okay, these are large whirls of water within an ocean basin. Okay, so we've got the North Pacific, and you can see them on the diagram to the right, the South Pacific, North Atlantic, South Atlantic, and the Indian Ocean. Okay. So why do currents move in a circular pattern? So because of Earth's rotation, and we talked about rotation and revolution way back at the beginning of the semester, okay, when we did astronomy, currents are deflected to the right in the northern hemisphere, and they're deflected to the left in the southern hemisphere. So if they're deflected one way in one hemisphere and another way in the other hemisphere, that is what gives us our circular pattern. And this is known as the Coriolis effect. Okay, and we have talked about this earlier in the semester as well. I showed you a video with two gentlemen on something similar to a seesaw, but instead of it going this way, it was on something in the middle, and then, yep, it moved around. And they tossed the ball back and forth to each other, okay? So, northern hemisphere to the right, southern hemisphere to the left. And then that's what creates that circular motion. So ocean currents and climates. Oceans maintain the balance of heat energy by ocean currents cycling between the equator and the polar regions. So we talked about the equator, and we talked about polar regions, when we talked about climate and weather, sorry. And nearer the equator, what kind of temperatures do we have? The equator. Hot, warm, hot, okay? And then near the polar regions, it's going to be cold, frigid, okay? So when currents from the low latitude regions move into higher latitudes, they transfer heat from warmer to cooler areas on Earth. So if they're transferring from warmer to cooler, they're going to transfer from the equator toward the poles. So ocean currents are especially important to coastal regions, okay? So near the coast, warm or cool the air temperatures along these coastal regions. Okay, so an example of this is the Gulf Stream, and the Gulf Stream actually warms the climate of Great Britain. So that is the importance of those coastal regions, because they can determine climate in other areas. This just gives us an idea of temperatures in North America. Obviously, it's warmer down where? But down where? In North America. Down south. Yeah. You got the right idea, but just look in here, okay? And then obviously they are colder towards the north. Speaking of colder towards the north, Pennsylvania actually had snow this past weekend, twice I think. Friday and Sunday, or Friday and Monday. Okay, so yep, it snowed twice up there. My parents lucked out because they were down. But up north and into Canada, okay, definitely much cooler temperatures. All right, next are deep currents. So these are opposite of the surface currents. So these are vertical. Okay, so we talked about surface currents, they're horizontal, and deep currents are vertical. Okay, and they result from density differences among the water masses. So factors that affect the density of seawater are the water temperature, okay, and the salinity, which deals with the salt content. So decreasing temperature and increasing salinity are what cause water to become more dense. So the colder and more salt, okay, the more dense the water becomes. So near Antarctica, surface conditions create the highest density water in the world, because it's what? Super cold, okay? So everybody see up here, if you look in the diagram to the right, so near Antarctica, that's where you see deep currents, and then up top is where you see your surface current. So evaporation results in increased salinity. We talked about evaporation when we talked about the water cycle. What is evaporation? Okay, so we take it up, right? But water is taken up into the air and turned into gas. Okay, so a simplified model of ocean circulation is known as the conveyor belt. So this is just a simplified model, and that's exactly what it looks like, a conveyor belt. And then one of the last things that we're going to mention today is upwelling. Okay, it is the rising of cold water from deeper layers to replace warmer surface water. So it's coming from deep. So think upwelling is coming from the bottom, okay, and it's replacing those warmer surface waters. So winds blow the warm surface water away, and then is then replaced by those cold waters that are found deep below, and they contain lots and lots of nutrients. So deep water is very rich in nutrients and therefore is brought to the surface, and that is super important. So upwelling, think we're pulling it up. So the wind shifts blows those surface currents away, and then the cold water comes to the top. So what is the actual impact of upwelling? It revitalizes the ocean and in turn keeps the ocean healthy. And that's super important because at the very beginning of this unit, we talked about water with the water cycle, but water that we find, okay, and what kind of water is most of the world made up of? Salt water. Okay, so it's important to keep our oceans clean and healthy.